Welcome back, everyone, to this discussion on group by operations, along with a discussion on the multi-level index in Pandas. A group by operation call allows us to examine data on a per category basis. So that means being able to answer questions like, what's the average per group or per category? Or how many rows do we have per category? So let's explore what this looks like in Pandas and what we mean when we talk about per category. Here we have two feature columns in this so-called data frame. We have a category column and a data value. And so when we're performing a group by call, essentially what we want to do is aggregate a continuous value per category. So here, the first step is to choose a categorical column to call with group by. And categorical columns are non-continuous. Essentially means that you have distinct groupings. So this category column has three distinct categories: A, B, and C. Unlike the continuous data value column, where we can see it's just some sort of continuous numeric call. Now, often beginners are confused and they think that categorical columns must be a string column. While it's more common for them to be string columns, keep in mind that they can actually still be numerical. So for example, the cabin class category on a ship or a plane, like first class, second class, or third class, those could just be represented as numbers 1, 2, and 3. Another example could be the model year for a data set consisting of cars. You can have the category of 1970, 1971, 1972, and so on, just different years. So keep that in mind. Once you've decided on the categorical column, then what you do is you call a group by call on that. And it has to be combined with an aggregate function call. So what we do here is what Pandas is actually doing under the hood is it takes in your data frame, and then once you decide on the category to group by, you essentially separate out all the other columns by the distinct categories. So we have all the data values for A, B, and C here. And then you decide on an aggregate function. For example, if we call the sum aggregate function, it's going to take the sum per category, essentially summing up all the A values, B values, and C values. So you can see the result here for A is 10 plus 5, 15, 2 plus 4, 6 for B, and then for C we have 12 plus 6 is 18. You could call a different aggregate function, such as the mean. So then it grabs the average value per category. And then you can have something like the count, essentially asking how many rows are there per category. This is different than sum because it's just asking you to count the instances per category. And in this case, they're all the same. There's 2 rows or 2 instances per category. So note that in Pandas, calling just group by itself creates what's known as a lazy group by object because it's waiting still to be evaluated by an aggregate method call. Let's explore this all further in Pandas in a Jupyter notebook. Okay, here I am in my Jupyter notebook. I've already imported NumPy and Pandas, and the data set I'm going to read is located within the Pandas folder. So we're going to say read CSV, and it's called mpg.csv. And this data set just has a bunch of information for lots of different cars: the miles per gallon, number of cylinders in their engine, displacement, horsepower, weight, acceleration, and then there's a model year, an origin number, and then the name of the actual model of the car. So what we're going to do is let's go ahead and start exploring how maybe performance has changed for the cars throughout the years. You'll notice that we first have to decide on what's the categorical column. So categorical column here could be something like model year. We have multiple instances of various cars per year. So maybe we're trying to answer the question, how has performance of miles per gallon changed throughout the years? So we could say, go ahead and grab the average miles per gallon for the years, like 1970, 1971, 72, and so on. Okay, so keep in mind this does take a little bit of knowledge of your data set to decide on what is a categorical column versus a continuous one. Another example of a categorical column here could be something like cylinders, because it looks like we have multiple instances of 8-cylinder engines, 4-cylinder engines, and so on. An easy way to check for this is to do something like, for instance, model year. And you could just ask for the unique values here. And you could see that there are multiple instances of 70 based off what you see in the actual series. And then you can see there's unique here. You can also do something that we've done before, which is value counts, which goes ahead and gives you the actual number of rows per category. It's kind of a very fast group by, but we'll show you how to do this manually in just a second. Okay, so we decided on our categorical column, which is the model year column, because I'm trying to answer a question like, how has miles per gallon changed on average per year? So then what we need to do is say df group by, and then you're going to group by and pass in what you want to group by. In this case, it's called model year. Now, I did mention that group by objects are lazy, and that means that if I just run group by model year, I get back this group by object. And what this means when I use the term lazy is Pandas hasn't actually done any work yet because it's still waiting on performing the calculations from the aggregate call. So it's still waiting for you to say, do you want the sum per category, the mean per category, etc. So what I can do here is say call.mean, and keep in mind there's a list of all the aggregate method calls in the Jupyter Notebook as well as in the documentation. So if we take a quick look at the Jupyter Notebook for this lecture, if we scroll down here, we see the group by method. I have a list here of all the most common options of things you may want to aggregate by, as well as the link to the documentation on this. But let's go ahead and back to grabbing the mean value per model year. So note what this is doing. Suddenly, the model year is now the index. So what it's going to do is it's going to grab the column you want. It's going to group by that particular category, set that as the index, and then it takes in the aggregate of what it can do. So if we come back here, you'll notice, we say df, we had a name column, and there's no way we can take the average of things like Chevrolet, Buick, and Plymouth, etc. So instead, it just doesn't bother to return that column. It's going to return back pretty much the numeric columns that it can perform a mean aggregation on. So here we can see MPG. You'll also notice that this is essentially a data frame that's being returned here with a named index. So if I was only interested in MPG, I could then, simply using brackets, grab the MPG column off this returned data frame. And so now I can see the average MPG per model year. And you can see that in the 70s, it starts off 17, 21, 18. But as you move further in time through the 80s, the miles per gallon starts to get higher, which is just a general trend that miles per gallon has typically gotten higher over time. Obviously, it may depend on the actual type of or model of car. Speaking of which, sometimes you want to actually group by multiple columns. So I mentioned that maybe miles per gallon is different by type of car, such as the number of cylinders in that particular car's engine. So what we could do, instead of just grouping by a single column to get the average, what I could also do is group by the number of cylinders as well. So technically, I could say df group by and then pass in a list. So I'll first group by model year, and then after that, I'll group by the number of cylinders. And then let's calculate the average value there. And notice we start to have what's known as a multi-level or hierarchy index, meaning model year and cylinders are not column names. And this is displayed to you by the fact that they're on this second line. The columns I currently have in this data frame that's being returned here are MPG, displacement, weight, acceleration, and origin. And we can confirm that by simply calling columns on the return data frame. And I see MPG, displacement, weight, acceleration, origin. However, if I take a look at my index, I have two levels of an index. I have this model year level and then the cylinders available for that model year. So it's grouping first by model year, so 1970, and then per cylinders. So I can see that the 4-cylinder engines had higher miles per gallon than the 8-cylinder engines. And then I can actually now start doing a comparison, not just per year, but per cylinders per year. So now I'm kind of adjusting for multiple categories, which makes sense because then I could do things like just compare 4 cylinders from 1970 on average to, if we scroll all the way down, 4 cylinders in 1982 on average. Again, higher. Okay, so the thing to keep in mind here is this has returned a multi-level index. So if I call index, I see here that it's trying to say that it's a multi-index with these tuples. So there's the outer index of 70 and then 4 cylinders. Then there's another instance of 70 with 6 cylinders, 8 cylinders, and so on. So let's talk about how to deal with and work with something that returns back a multi-level index, because it's going to be a bit trickier to try to grab something like MPG just for 1970 with cylinders of 6. And as before, I could just grab every instance in a column by saying something like MPG. So again, now I have this kind of multi-index series here. Okay, so before we move on, I just want to quickly also show you that instead of just calling mean or sum at once, you could also do something like describe, which is df group by. Let's go ahead and just do model year. I could say describe, a method we've seen before. And so what this does is it shows you everything here. Miles per gallon, the count for that, mean, standard deviation, min, percentiles, etc. Sometimes it's easier to read this if you transpose it, as I've mentioned before. And so what this does is it returns back this slightly complicated data frame, but it essentially shows you all the aggregation methods possible for a single column. So if I was interested in what is the average miles per gallon for 1971, I would come to 1971 model year, miles per gallon, average, and it's 21.25. I can also see the minimum miles per gallon value as well as the maximum miles per gallon value for each of these years. So just something to keep in mind in case you want to just quickly grab some statistical analysis of a data frame. But I mentioned that we kind of want to focus on this idea of this multi-level index and then how to deal with this multi-index object. So let's say year CYL for cylinder is equal to DF. I will call group by, and again, we're going to group it not just by model year, notice I'm passing a list in here, but also by cylinders. And then let's just grab the average value just so it's not overwhelming. So now that I've assigned this to a data frame, I can take a look at it. And here's what we had before. Essentially the average of miles per gallon, displacement, weight, acceleration, origin, etc. And then it's the average, not just per year, but also per cylinders. So we just explored the index, and I can actually grab the index names, which is model year and cylinders, by calling .index.names. And so reports back model year and cylinders. And this can also then report back the levels available. So if we say index.levels, it gives you the outer levels. Notice it's a list of lists, multi-dimensional array here. And we have the levels for the outer level index, which is the model year, and then the possible cylinders. Essentially showing you all the possible years and all the possible cylinder values. Keep in mind, not every cylinder value is present for every year. So there are no 3-cylinder cars for 1970, for example. Okay. So let's talk about now working with this index. What I can do is I can grab based off the outside index using .loc, just as I could with a normal data frame. So if I have this year cylinder, and let's go ahead and imagine that I'm only interested in grabbing on this outside model year for the year 70, I can simply say .loc 70, and the .loc commands are going to work in reference to the most outside level index. So then this returns back the values for 1970. Keep in mind it just drops that outside level index, so then you only see cylinders. What I could also do is then pass in a list here. For example, I could then say, okay, give me 70, comma, and then also as, let's say, 82, the last year value. And since I'm asking for more than one year in order to distinguish, it's going to include model year as the outside level index here. So then I could say, okay, let's check out cylinders for 25 miles per gallon versus in 1982, cylinders for 32 miles per gallon. So .loc, it's going to work on this outside level index. If you only wanted to grab a very particular row, for example, let's say I want 8-cylinder cars for the year 1970, then you're going to say year, cylinder, .loc, but then you're actually going to pass in a tuple. And a tuple essentially corresponds to the output we saw earlier when I called .index. Notice there were these tuples here. Well, all I need to do is, for example, grab one of them, like 4-cylinder cars for 1970, and then pass it in here, and it returns back that exact row as a series. Previously that we saw, if I say group by, and then I use 2 or more columns, and then perform some sort of aggregate operation, what happens is we go ahead and run this, and I check out year cylinder. I have this multi-level index. I have the model year level on the outside and then the cylinders level on the inside. So again, this index is labeled model year, outer level, cylinders, inner level. And technically you can have more than just 2 levels. And you can see .index.levels reports back the options for each level. And then we saw that the multi-index actually gives you these tuple pairings, or if there's more than 2 items, if you have more than 2 levels. But essentially, we can see we have 4 cylinders for 1970 row, 6 cylinders for 1970 row, and so on. And if you want to grab just one of these rows, like 1982 6 cylinders, and just grab this highlighted row there, then what you do is you just say .loc, and as a tuple, you can provide that tuple pairing. Okay, but now let's go ahead and move on and talk about using something called a cross-section, which is a more general purpose way of grabbing something that has this multi-level index. And the method call is .xs. So what I'm going to do is quickly take a look at year cylinder. I can see it right here. I have model year and cylinders, and then I'm going to call .xs, which is, if we take a look at here, it's a cross-section. So essentially what this does is it takes in a key, an optional axis. By default, we'll keep it at 0, since that just means look at the rows, and we want to have our multi-index levels on the rows. And then we can also see that we have this level option. And the level just refers to what actual index you're looking at. So are we looking at the model year level or the cylinders level? So let's imagine I wanted to grab just model year for 1970. The way this works is we provide a key. In this case, the key is actually just the integer, 70. And then I have to tell it what level I'm looking at. So I'll say, I'm looking at the level model underscore year. And if I run this, I get back that subsection here for that particular key at this particular level. Something to keep in mind is when you're using cross-section, it only takes in a single key as the value. So if you wanted to try something like 70, 80, this actually wouldn't work. So if you run that, it's going to say key error. I can't find 70, 80 as a key. So you can't actually pass in a list to get multi-levels. Instead, if you were dealing with this data frame and for some reason you wanted the year 1970 and the year 1980, as we showed you in the previous lecture, you just call .loc and then pass in that list of options. You'll say, okay, give me 70 and give me 80 as a list. Run that, and it works automatically here on the outside index. So if I had the capability to already use .loc, what's the use of cross-section? Well, what I don't know how to do so far is grab something based off this inside index. For example, let's imagine I wanted to grab only the 4-cylinder cars, but I wanted to do it for every single year. I can't really do that easily with .loc. Instead, that's where we're going to use this cross-section tool. So what I'll do here, let me just run year cylinder so we can see it. Again, what I'm looking for are the instances of 4 cylinders for every single year. So I want this first row here, then I want this next row, then this middle row here, etc. So I say cross-section, XS, and the key I'm looking for is 4 cylinders. However, I just need to let cross-section know that the level I'm looking at is this cylinders level. So I copy and paste that here. And then when we run this, I get back this nice data frame that shows me the model year and then the values. Something to keep in mind is that when you're asking for a particular level, like cylinders, or up here, we're asking for the level model year, that actual level then is not shown in the results because there is only one attribute or one value for that level. So what I mean by that is the reason we're not seeing model year here is because they're all the same. It's all 1970 or 70. And the reason we're not seeing cylinders in this output is because it's all the same. It's 4 cylinders. So just keep that in mind. If I just look at this data frame on its own without knowing the code that produced it, I actually have no way of telling what cylinders this is referring to. So when I actually assign this to some sort of variable, I would probably want to say something like for cylinder is equal to, etc., because the key itself is not super apparent what I chose in the actual output. So just a little tip to keep in mind as you're working with this. And then another thing I want to know is people then ask, rightly so, if I'm looking at year cylinder, and let's say I actually want the cylinders for 6 and 8 for every single year. Well, that leaves us in a bit of a conundrum because I just told you we can only put one value as the key. And if you're trying to then select certain cylinders, then it's probably much easier to filter out those values before you run the group by call. So you should always keep in mind that what actual values are you looking for in the final results. And if since the beginning you were only interested in the cylinders for 6 and 8, then you should filter that out in the original data frame first and then just call your group by. That's going to be a lot easier to both do and read than trying to mess around with .loc and that cross section to get those results. So, for example, if you only want the aggregate for cylinders 6 and 8 for every year, what you should do is just before you even call group by, say, okay, give me data frame, where data frame of cylinders is in, and then you pass in the options you're looking for, like 6 and 8. And so now we see here our data frame where we only have 6 and 8 cylinder cars. Once you've done that filter, then go ahead and call group by cylinders or model year or whatever you're looking for. So in this case, we can go ahead and just do both, model year and then cylinders, and then grab the mean that way. So this gives you that result of only 6 and 8 cylinders for that particular model year. So a lot of times I see beginning students get confused. They're trying to figure out how to do something like this using .loc or .cross section when it's actually just a lot easier to filter out your data frame first and then call group by on what you want. So always try to keep that in mind as far as what's the simplest way to get the final results you're looking for. And often you'll find it's a lot easier to do the filtering and conditional filtering on the data frame first and then do your aggregate functions. Okay. So finally, what I want to show you are things like swapping the levels and sorting the multi-level index. So for example, we come over here. I still have this year cylinder object, and currently the outer level is model year, inner level is cylinders. Technically, I think that makes the most sense, but if for some reason you wanted to swap these, make cylinders the outer level and model year the inner level, all you need to do is say swap level, open close parentheses, and it will swap it for you. So we can see here now cylinders is on the outside and model year is on the inside. Whether or not that's useful kind of depends on the situation, but it is available for you to swap the levels. Okay. And then finally, let's go ahead and show you how to sort the multi-level index. So right now it's sorted model year from earliest model year to the latest model year. But if you wanted it in descending order, starting from the most recent to the bottom, then actually all you need to do is just before say sort index, and then you can specify which index you actually want to sort by. So for example, I can say the index I want to sort by, the level is model year level, and I actually want it with ascending is equal to false. So it's the same command or same method that we saw earlier, except now we actually just provide the level parameter that we're dealing with. So you run that, and you can see now we have it in descending order. Something to keep in mind, if you start looking at inside levels and start sorting by that, then you may start breaking up this grouping. For example, if we say cylinders, ascending is false, you'll notice suddenly it breaks that relationship because you have 8 cylinders for multiple years. So just keep that in mind. Usually when you're sorting, it makes sense to sort by the most outer level. Last thing I'm going to show you in this particular method is a more advanced method that allows you to customize what aggregate functions you want per category. It's a pretty neat advanced feature. We won't really see it too often, but hopefully in your own work, you may find it helpful sometimes. So let's jump back and take a look at our original data frame. And as I mentioned before, when we're thinking about doing group by, we've just been applying the same aggregate function to every single column here. So we did the mean of MPG, mean of cylinders, displacement, horsepower, weight, etc., depending on what you actually choose to group by. But sometimes it doesn't actually make sense to do the same aggregate function on every single column. So what I want to show you is how you can actually specify a particular aggregate function or group of aggregate functions for a particular column. And the way you do that is through the .agg, which is the generalized aggregation method. So we'll say df.agg, and this is then going to aggregate, and it can actually take in a list of string calls. And the string calls are going to match up with the method name in the table in the lecture notebook. So recall in that lecture notebook, let me just bring it in here real quick. At the very top of it, I mentioned, scroll all the way to the top, that there are some common options here. There's also a link to the online documentation. But you'll notice we have mean, sum, size, count, etc. So the string calls you're about to see me type in, they come from this list of common options. But what I really want to show you here is with the aggregate method, you can essentially say, okay, give me the mean of the MPG column, but the standard deviation of another column. So to show you how this is run, let's first do it on all the columns, and then we'll show you how to pass in the dictionary. So on all the columns, if I wanted mean and standard deviation, here inside of this add call, let me zoom in one level here. Inside of this add call, I say, give me the standard deviation and the mean. And then I run that, I see aggregation, standard deviation, and mean. And here it is as the index, standard deviation, mean for all the columns. Now you'll notice that some of these don't really make sense. Standard deviation of the model year or the origin doesn't really make sense either. So some people then would take this and just filter out by what they're actually looking for, like MPG, for instance. But let's imagine that you only wanted some aggregate functions for some particular columns. Well, the way we can do this is we actually pass in a dictionary into the aggregation call. And this is this advanced method that's really useful as you start to upgrade your skills with pandas. Now what you do here is you pass in a dictionary where the key is the column you're interested in, and then the values are a list of the methods you want to call. For example, let's imagine I wanted to call max and comma mean for the MPG column. And then as another key value pair in this dictionary, I'll go ahead and grab weight and then say, well, I'm only interested in the mean of the weights as well as the standard deviation of the weight. So note what I'm doing here. I'm actually applying specific aggregation functions to a specific column, and they actually don't need to match up with the other aggregation functions I'm passing in for another column. And when you run this, you get back this nice result where you see your columns, the original ones, MPG and weight, and you can see the max and mean for the values you're interested in, and for example, the mean and standard deviation for the weight column. Now, keep in mind, it's going to fill in a nan value for things you didn't call. Since I didn't call standard deviation on MPG, it just fills it in as a null value. And this will often make sense depending on your particular data set. Because for whatever reason, maybe it didn't make sense to grab the max for the weight here, etc. So this is just a kind of most advanced method you can use to apply particular aggregation methods to particular columns. Okay, there's a lot more examples in the lecture notebook. We really won't actually execute something like this on our own in our projects later on in the course, but I do want you to be aware of it because it's a super powerful tool, especially when you're writing things like reports for other people, and you don't want them to start thinking, oh, why did they report some aggregate function for a column where it doesn't make sense? So this allows you to just replace it with null values if for some reason it doesn't make sense for that particular column. Okay, thanks, and I'll see you at the next lecture.